This time we're going to look at a categorical syllogism involving particular statements, that is, I statements and O statements. A complication arises when dealing with such statements. Here's a syllogism. Some pets are not furry creatures. Some capybaras are pets. Therefore, some capybaras are not furry creatures. The first premise is an O statement, so let's refer to the two-set diagram for an O statement. We would put an X in the subject minus predicate region. In this case, pets that are not furry creatures, indicating that there's at least one of those. Now find the corresponding zone on the three-set Venn diagram. It's here, regions 1 and 2 together. This is where the complication arises. If I put the X here in region 2, that would signify that there's at least one thing in this specific region, that is to say, a pet that's not furry, and it specifically is a capybara. That's more information than the premise is giving me. I only want to represent exactly the information that the premise is giving me, so I can't do that. But if I put the X in region 1, I have a similar problem. That would signify that there's at least one pet that's not furry and specifically is not a capybara. So I can't do that either. The solution is to put the X on this line. It's not in region 2 and it's not in region 1. So we're not saying that either of those regions is occupied, but it is inside the zone comprised of regions 1 and 2 together. So it signifies that the entire zone that I've put in blue here isn't empty. Region 1 could still be empty if region 2 had at least one occupant, or vice versa. Or both could be occupied, but both can't be empty. Although it's not technically what it means, you can think of the X as representing that one individual that has to be there, and it's on the fence between the two regions. It's a simpler way to think about it, and it will produce correct results, although, as I said, technically that isn't what the X here means. Moving on to the second premise, which is an I statement. Let's look at the I statement diagram. We need to mark the intersection of C and P as having at least one occupant. Going back to the three-set diagram, that corresponds to regions 2 and 3. We have the same issue about the regions being more specific than the zone we're trying to indicate. So we put an X on the line that divides this green region into two parts. Now, stop diagramming and look to see if the conclusion is forced. The conclusion is an O statement, that some capybaras are not furry creatures. So first we need to find the zone corresponding to C minus F, the capybaras that are not furry creatures. It's here, regions 2 and 5 together. The question is, does that zone have to have at least one occupant, or could it still be empty? Now there are two X's touching it, but they aren't inside of it. Remember, this X just means that both regions 1 and 2 can't be empty. But that doesn't mean 2 can't be empty. And this X means that both regions 2 and 3 can't be empty. But again, region 2 could still be empty, as long as regions 3 and 1 are both occupied. And if there's any possibility for the conclusion to be false, then the argument is invalid. So the upshot is, if the X ain't inside the conclusion zone, then the argument's invalid. If we need to diagram a syllogism involving a particular statement and a universal statement, a further complication arises. The two pieces of information can interact in a way. The shading can affect the placement of the X. Here's an example. Some capybaras are not pets. All capybaras are furry creatures. Therefore, some furry creatures are not pets. We set up our circles and label them. Notice how this time furry creatures is the minor term, so it goes on the left, and pets is the major term on the right. So the diagram's orientation changes when the terms occupy different places in the syllogism. It's advisable to diagram the universal premise first, even if it's the second premise in the syllogism, because it can affect the placement of the X. If you mess up and diagram the particular statement first, it's not the end of the world. You just move the X later on. But in any case, let's start with the universal premise. All capybaras are furry creatures. We find the subject minus predicate zone. reserved for capybaras that are not furry. Here it is, regions 1 and 4 together. We shade that zone, indicating there are no such things. Now turn to the first premise. Some capybaras are not pets. Let's find the zone, capybaras minus pets. It's regions 1 and 2. I'm outlining it in blue. Without the other premise, we would put an X on the line dividing the zone into two parts, in order to indicate that this zone has at least one occupant. It's not empty. However, in this case, region 1 has been shaded because of the other premise, indicating that it is empty. That means region 2 is the one that's occupied. So we put the X squarely in region 2 this time. It really helps to identify the entire zone that we're talking about first by outlining it or something similar. Then you know the X has to go inside of your outline. And if one region in the outline zone is empty, the X goes inside the other one. Now stop diagramming. It's time to see if the conclusion has automatically emerged. It's an O statement. Some furry creatures are not pets. We check to see, is the zone F minus P forced to be occupied, or could it still be empty? Let's outline that zone in red. Here it is, regions 2 and 5 together. And there's an X completely inside the red outline. So there is at least one furry creature that's not a pet. Notice that the X is not exactly in the place we would put it if we were diagramming the conclusion, because we would put it on the line. That doesn't matter. All we need to check is that there's something inside the region somewhere. It's being completely inside region 2 satisfies that requirement. It means there's a furry creature that's not a pet. We also have more specific information, that there's at least one that's also a capybara. But again, that doesn't matter. If there were an X in region 5, that would satisfy the requirement as well. In any case, the argument is valid. I obviously haven't covered every syllogism you could encounter. There are 256. But at this point, you should have everything you need to diagram and evaluate every one of them. So practice on the examples provided and let me know if you have any questions.